All right. So what I'm going to do, suppose we're given something like this, and suppose we do not know what is arcsinge in terms of length or in terms of volts. Okay. So what I'm going to do is I'm going to do the most basic thing. Okay? The most basic thing, as we always do it, guys. As we always do it. So what's going to happen is, let me take a screenshot of what we attended. Very quick, guys. Okay. So, okay. Sorry about that, guys. So if I'm given something like this and I do not know what is arcsinge in terms of that, I'm going to use the most basic arithmetic. We're going to let something be equals to something. Yeah? We're going to let arcsinge be equals to 1. Okay. Then by the definition of inverse multiplied by its original function, we're going to get such a sinh 1. Okay. So we know that the usual thing that we're going to do is solve and expand this and whatever. But in this case, I want us to do something. Do you guys remember this thing you're doing in differentiation called explicit differentiation? Explicit differentiation. So this time I want us to use explicit differentiation and say, actually, from this particular thing, let us just derive by x, d dx of x is equals to d dx of arcsinge y. Okay. Okay. I hope now you can see the idea that I'm trying to bring forward. Okay. So the derivative of x, oh, actually I'm using the wrong that one. Okay. So as I was saying, from here, I'm just going to use explicit differentiation. d dx is that d dx of sinh y. Okay. So from here, we are going to see that this thing implies that, this implies that we're going to have the derivative of x is just 1. But now this is the derivative with respect to y, not x. So we're going to use the chain rule. By the use of the chain rule, or do you want me to explain to you what's going to happen and stuff? If you feel like I should explain to you, please let me know. Try to explain. We're going to have cosh y dy dx. Okay. But let me just explain. Let me just explain, because I don't want people to say, yeah, they wanted explanation, but we didn't get it. What happens is we do not have this thing with respect to x, but we're differentiating with respect to x. So what we do in mathematics, we introduce, we're going to have d dx, and then we're going to introduce 1 by introducing dy dy, then have sinh y. Okay? What happens is we're just going to swap the two. Just going to swap the two. So what we're going to have is d. Okay, let me just have dy dx multiplied by d dy of sinh y. Okay, so as you can see, d dy of sinh y is just cosh. So dy dx, d dy of that is just cosh 1. It's just cosh 1. So that's what we get, guys. This is what we get exactly. Yeah. Okay. So from here, I'm just going to do that thing that we have always done. We take each and every term to one side of dy dx. So what I mean is I'm going to have dy x to be equals to 1 over cosh y. All right. So from here, I'm going to say, I do know some identities of this particular hyperbolic function. And the identity I'm going to use in this case is just dy dx is equals to 1 over the square root of. Now, you guys remember 1 minus, it's actually 1 plus sinh squared y. Okay. Now, before I move on with this thing, I want us to look at something before I move on with this thing. It's 1 over square root of 1 plus sinh squared y. You remember this when we were discussing the slides, we had this identity saying that if we have got what do you want to say, guys? You know it. Please remind me, guys. Please do remind me. Oh, it said if you've got cosh squared x plus sinh squared x, it's actually minus sinh squared x is equal to 1. You remember this thing, guys. Yeah? So what I just did here was, because I know this, I just said cosh squared x is equal to 1 plus sinh squared x, which is this part. Yeah? But in this case, my x is y. Yeah? And then I said, oh, but I don't want cosh squared. Let me take the square root on both sides. So I got cosh x is equal to the square root of 1 plus sinh squared x. So this is the idea I used. Yeah? This is just the idea I used. Okay. So I went back and I said, okay, let me just remove this part. Okay. So I went back and I said, okay, since I've got this idea in mind, where I've got dy, that particular thing, I can introduce something because I know why, right? I do know why here. So I'm going to say that rather than writing dy, I'm just going to write d dx, but my y is this. Just sinh x, that is, this is equals to 1 over the square root of. Now I'm going to have 1 plus, what is sinh y? Sinh y is just x, so I'm going to have x squared. Yeah? Are you fine with that idea, guys? Sinh y is just x. This is where the part gets very, very easy. I've just proven to you that arcsinh x is just equals to 1 over 1 plus x. This is the simplest root, but it has so many things that you need to put together on this particular thing, right? Okay, so I said to you, this is just a direct way to do it, and I can show you the second way to do this particular thing by using that definition. That definition of, we know that arcsinh of x is just equals to ln of x plus the square root of x squared plus 1. Okay, so we're going to use this idea now and say, because we know that the derivative of this should be the derivative of that, then therefore the derivative with respect to x of arcsinh of x is going to be equals to the derivative of ln of x plus the square root of x squared plus 1. Okay, so what's going to happen is, if I do have something like this, I'm just going to consider the derivative of this. So the derivative of this alone, take note, guys, let me call this star. The derivative of star alone will just give us ln is just 1 over x plus the square root of x squared plus 1. And then this side I'm going to have 1 plus 1/2, have x squared plus 1 to the negative 1/2 multiplied by the derivative of the inner function, which is just 2x. And you can see that the 2 and the 2 will give us 1. 2 and the 2 will give us 1. And then we're going to have 1 over x plus the square root of x squared plus the 1. And then it will be multiplied by 1 plus x all over the square root of x squared plus 1. Okay. So what's going to happen is I'm going to introduce this denominator using this 1. This part you have seen it already, guys. I'm just doing it just because I want to show you that in any way that you used to do this, you're going to get the same solution. So this is going to be equal to 1 over x plus the square root of x squared plus 1. So I'm going to skip the step where I'm going to show that this is equal to this over there and just write the square root of x squared plus 1. And here we're going to have the square root of x squared plus 1 plus x. And then you can see that this and that give us the very same solution. Our solution becomes 1 over the square root of x squared plus 1. But as we know, this does not change anything, guys. This does not change anything because it's a plus and a plus between two terms. This is exactly the same as writing the square root of 1 plus x squared. So you do not need to worry much why this one came first and that one. No, it doesn't matter. It doesn't matter. So this thing is just a derivative with respect to x of x. Okay. So these are the two ways of proving that this thing is true. I personally enjoy using this one. If I'm not very nice with differentiation, I enjoy this one. The first method. Let me call it the first method. This is just the first method, and this is the second method. Okay. So the first method, it is very arithmetic. It is very simple if you understand this rule, the one that I was writing for you just here, the one that I wrapped off. If you understand this, let me just write it here as a note, and let me write it here as a write it here. The one that says cos squared x minus sinh squared x is equals to. All right. Any questions, guys? Arithmetic is just basic, simple, and I would advise you if they say that show that the derivative of this thing is equal to that, use this one. Just use this one, guys. Please. I beg of you. I beg. Yeah? Any questions? Any questions? Chat room question. Oh, you can't see my screen. Can you see it now? Oh, I didn't see that one. And I've written so much. If you still can't see, you know.
So can you explain your step 1?
My first step. Should I re-explain again? Okay, but please take note. I'm gonna skip certain steps because I told you that this step is related to this. Yeah? Or do you want me to redo like the whole thing and show you this thing again?
Like, I don't understand for the last step.
This step, yeah.
Yes.
Okay. Let me just redo the whole thing such that everybody and somebody who didn't understand the thing can get it again. So suppose that they say find the derivative is equal to this. Okay, let me just write it. Show that or prove that these things are equal. Me, guys, I don't like working hard. I've got a problem with working hard. Eee, Jesus. Got a problem. Okay, let me just this. Okay, so we can work smart. So we need to just show that this thing is equal to 1 over square root of 1 plus x squared. Okay. Okay. Now, I said to you guys, it's an arithmetic that we have used before and we do understand it. And I said to you guys, for us to have simplicity in this particular thing, let us let y be equals to arcsinch x. Ne? And then I said this will imply that if we multiply on both sides by the original function, we're going to have x is equals to arcsinch y. All right? Hey, hey, woo, Jesus. X is going to be equal to, because we are multiplying by the original function. So we're going to have sinh y, not arcsinch. Sorry about that one. It was a terrible mistake. Okay. So since we have got this, I said to you, okay, guys, this time let us do something different. Let us not do the one thing that, you know, that expand this and stuff. We don't want to expand that. It's not, yeah. I said to you, let us use implicit differentiation. Implicit differentiation. And let us differentiate on both sides with respect to x. F dx of sinh y. And then I said to you, according to implicit differentiation, we need to introduce the chain rule here. And I explained to you the chain rule method of this thing, right? I said to you, we had d dx of sinh y, but this thing is written with respect to y, not x. So the only way to introduce y is if we are going to say d dx multiplied by dy over dy, because this is just one, right, of sinh y. Yeah? And I said to you, let us just swap the two, have dy dx multiplied by d dy. You see this d came here and this dy came here. So this is what just happened here. And have sinh y. Now we are differentiating this thing with respect to y, multiplying by that. So we're going to have dy dx cosh y. Ne? So meaning that the differentiation with respect to x of this thing will just be equals to 1. And then the differentiation with respect to x of this thing would be equals to cosh of y multiplied by dy dx. Are we fine, guys? Okay. For the fact that you're not answering, I will say maybe you're fine. Now, what happens is I'm going to separate the terms and just be left with dy dx. Have dy dx be equals to 1 over cos y. And I said to you, wait a minute. Why don't we just say, since we know that cos squared y minus sinh squared y are equals to 1. And let us just rewrite cos y. Okay? We are going to have cos squared y is equals to 1 plus sinh squared y. And say take the square root on both sides and have cos y equals to the square root of 1 plus sinh squared y. But now, before we run and say many things, many men and whatever, what is this thing denoted as? And if you can go back, we see that sinh y can be written as x. Oh, that's where the beautiful part comes. Ne? Sinh y can be written as x. But since this one is squared, we're going to write this as x squared. Then therefore, rather than writing cos y, we can go back and say, this thing can be rewritten as dy dx of 1 over the square root of 1 plus sinh squared y. Do you see that, my man? Ne? And I said to you, but wait a minute. What did we denote y as? We see that we denoted y as sinh y. And I said, okay, since it's arcsinh x, I'm going to write d dx of arcsinh x, which is already what we are looking for. This, right? This is the first part here. This will be equals to 1 over the square root of 1 plus sinh squared y. And I said to you, but sinh squared y is written as x squared. Then I can simply rewrite this as 1 over the square root of 1 plus x squared, which is okay. Did I answer your question, my man?
Yeah.
Okay. Any other questions, guys, before it's 3 o'clock? Because now I can take all the questions you have. And to tell you the truth, guys, we have successfully completed the theory behind hyperbolic functions. Now you can just go there and do questions. Now I'm going to expect questions and more questions from you in there. So this is just the second. So the second way I showed you using cosh, I've cosh actually, and I showed you using arcsinh, and with arcsinh, this is how it works. If you understand differentiation. But for the purposes of repeating the whole thing, let us just repeat also this one, that does not get wiped off minds like I'm wiping off this. Yeah. Okay. So the explanation behind the second is, since we know that arcsinh x can be rewritten as ln of x plus the square root of x squared plus 1, right? So we're going to have the square root of x squared plus 1. And I said to you, if we want the derivative of this, we can just simply find the derivative of it instead of just finding the derivative of this. And people said, no. So since we got it like this, I'm just going to say, okay, rather than find the derivative of it, find the derivative of it, meaning that d dx of arcsinh x will be the same as d dx of ln of x plus the square root of x squared plus 1. Okay. So from here, okay, still got 10 minutes. From here, I'm just going to deal with star. I said star is this one, right? I'm just going to deal with star and say its derivative, d dx of star, is given by, this is exterior, this is star. Let me say star. Star is this one. Okay. The derivative of star with respect to x is given by, and I said to you, every time when you use ln, you must remember that you must have 1 over everything that is inside the bracket, the square root of x squared plus 1, multiplied by the derivative of what is inside the bracket. The derivative of x is 1. The derivative of this thing is 1/2, multiplied by x squared plus 1 to the negative 1/2. Why does it become negative 1/2? It's because this can be written as x squared plus 1 to the power of half minus 1, it becomes minus half. And then multiply by the derivative of the inner function, which is 2x, multiplied by the derivative of the inner function, which is 1. So we can write it. So just leave it. Yeah? And then you are going to have this, and that will give you 1. And then what you're going to have from this part is you're going to have 1 over x plus the square root of x squared plus 1 multiplied by, and I said to you guys, specific and explicit, that I'm going to rewrite the 1, okay? But let me not rewrite it now. So I'm going to have x, this x is still there, divided by the square root of x squared plus 1, because this is how we can denote this. Okay? So this thing will be equals to 1 over x plus the square root of x squared plus 1 multiplied by, I said to you here, we're going to denote this as the square root of x squared plus 1 all over the square root of x squared plus 1, plus we're going to write this thing the way it is, because we are fighting for them to have the same square root. Yeah. Okay. You don't see this. All right. So a derivative of star is given by this so far. Okay? So what is going to happen is that we have got the common denominator here. So we're going to rewrite this as 1 over x plus the square root of x squared plus 1, and multiply that by, we're going to have the square root of x squared plus 1 plus x divided by the common denominator, which is x squared plus 1. You see that, guys? Eh? And as you can see, this and that are exactly the same. This and that are exactly the same. And therefore, since they're exactly the same, they are equals to 1 because there is multiplication between two terms. And therefore, what we are left with in the numerator is 1. What we are left with in the numerator is x squared plus 1. And I said to you, this thing is exactly the same as rewriting this as 1 over the square root of 1 plus x squared, because it is plus 2. Are we fine? Okay. All right. So with that being said, let me just take the screenshot of the people who attended, and we can call this okay. Okay. In the absence of questions, I'm gonna repeat. We are done with these things. We're just gonna be doing questions and questions and questions, more questions. So please, guys, do go through your textbook. I'm gonna ask your lecturer to put together a tutorial sheet. And another thing, I was asked by an individual, why am I not posting or putting together memorandum for the tutorial sheet? And I said to that person that the reason is because it's my duty as your tutor to be able to help you understand the questions. And rather than just giving you solution to that particular thing, where you will think that you understand it, you really don't understand what's happening where. Because I can just give you this thing, and let's say, for instance, I didn't write this step here. I didn't write this step here. And I also didn't write this step here. I didn't write this step here. And then I just say to you, this because this is true, this is this, and this is that. Now the question is, how did we go from here to here? You get what I'm saying, guys? So the dangers of me not allowing ourselves to be able to, what do you call this? To be able to have that memorandum is because of the mere fact of me trying to understand and make you understand that this whole thing can be done in this particular way. So, do you have any questions, guys, with what we've done so far with regards to hyperbolic functions? If you do not have any questions, I'm still going to suggest that there is one-on-one sessions, which will be happening on Wednesday from 11 to 4. Please do let me know if you did the one-on-one session about anything we've done so far. It's not only about this, it's about anything we've done so far this course. Okay, so do we have any questions before I end this session? Do you have any questions? But 5 minutes. But 5 Okay. In the absence of questions, I would like to say thank you for attending this session. I hope to see you on the Friday session, as we'll be doing only questions, guys. As we'll be doing only questions. For further information, I'll send you in the group chat. Please do enjoy the rest of the day and stay safe. Thank you, guys. Thank you for the session.
Thank you. Bye-bye.
Uncle Timothy.